Hello everybody, and welcome to example 3 on page 9. This is going to be another example of a vector space, and it's going to introduce some new notation for us at the same time, so let's read this together. So they start us off with a set that looks like f of RR. That notation represents the set of all functions with domain R and codomain R. And it turns out that this is also an example of a vector space. Okay, again, if this is really a vector space, then we should be able to define what we mean by, or we need to define what we mean by addition and scalar multiplication. All right, so to do that, let's start with a couple of functions. So given functions f r to r and g r to r, and a scalar c in the real numbers, our operations are defined as follows. Okay, so first thing we need to define is what do we mean when we add two functions together, f plus g? Okay, well, that function we can define naturally by just saying that f plus g of x is going to be the sum of the two outputs of f and g separately, f of x plus g of x. Okay, and then similarly, what does it mean to multiply a function by a scalar? Well, that's going to be the function, so that if we substitute an x in, we just take the scalar c and multiply it by the output value of f. Okay, and we're making a claim here that this is a vector space with these operations. So to formally verify this, we would need to go down that list of 8 vector space properties and confirm that this set has all of those properties. We could do that. That would be very tedious, so we're going to skip over it. And the comment I'll make is you can just assume that somebody's done that and just regard this as a vector space for the rest of the course. Okay, what would be some examples of vectors in this vector space? All right, well, basically, it would be any function that has domain R and codomain R. So for example, how about a nice parabola? X squared minus 2x plus 1. Okay, that's a function we can certainly substitute any real number x in, and we'll get a real number out, so that would be a valid vector in this vector space. Or how about g of x equals e to the x? That also works. That's a function with domain and codomain R. And you could even get fancy and choose strange functions, like maybe something piecewise. H of x equals 1 if x is greater than 2, or negative 1 if x is less than or equal to 2. That function has a big jump in it. It's discontinuous, but it's a valid vector in our vector space because it has a domain of R and a codomain of R. We can substitute any real number that we want to in it. Okay, and you can think about maybe some other vectors that might be in that vector space.